We won't do 10. We'll maybe do 5. This time I'm going to turn the timer on. Up until now, we've had the timer off. So let's see whether that makes a difference.
-1.
What's 8 times 2?
That's what 92 or -92.
96. 8 times 2 is 16. So that last digit has to be a 6.
12. -12. 11.
Positive or negative?
-11. No, 6. -40. -1. -17.
Good. Not bad. There's one more here.
Oh, okay. -2.
All right. That's pretty good, actually. You were getting most of those in under 10 seconds. All right. Today, let's talk about something other than factoring. Let's talk about simplifying square roots. What's the square root of 9?
3.
What's the square root of 18?
9.
No, I don't know that you've learned this yet, so let's talk about this. If I have the square root of a times b, then that is the same as the square root of a times the square root of b. So the secret to doing 18 is to factor it into two numbers, one of which is a perfect square.
So 14.
How about, in other words, I could rewrite that 18 as 9 times 2, right? Which means that it's now the square root of 9 times the square root of 2. Well, what's the square root of 9?
The square root of 9 is 3.
So our answer is 3 root 2. So the goal, whenever you're simplifying radicals, is to find a factor of 18 that is a perfect square number.
So it would equal 1 and the square root of 8.
No. It's got to be two numbers that are factors of 18, like 9 and 2. 9 times 2 is 18.
Oh.
Okay, so it's got to be numbers that multiply together to give you this. Let's do another one, just because it's a good illustration of what you can and cannot do. How would I do square root of 20? What's that the product of? Factors of 20, one of which needs to be a perfect square.
10 and
Well, notice that that is factors of 20, but neither of those numbers is a perfect square. And the goal is to get a perfect square number so we can eliminate the radical sign. But what if I did 4 times 5? That's also 20. And this is a perfect square number, which means I can eliminate the radical sign and put a 2 there. So root 20 is 2 root 5. Got the idea?
Yeah.
Okay. How about 40?
40, so, wait, can't you do that just regularly?
Well, what do you mean regularly?
Like, this way, no you can't, never mind.
Well, regularly would be putting it in a calculator and coming up with, this is an irrational number. In other words, it's not 6 times 6, that would be 36, but it's 6 and change. Maybe something like that. If I square this number, I would get 40. So that would be the regular way. But we're not trying to come up with a decimal answer. We're trying to come up with a radical answer. So what are factors of 40, one of which is a perfect square? I tell you what, before we go any further, tell me the perfect square numbers. There's 1.
1,
There's
4,
that's 1 squared. That's 2 squared.
8,
No, what's 3 squared?
I don't know. Oh, 6,
3 times 3.
or 9.
Okay.
9.
What's 4 squared?
8, or wait, 4 squared? Oh, that would be 16, right?
What's 5 squared?
5 squared. 25.
6 squared?
36.
7 squared?
49.
Okay. You see that list of numbers?
Yeah.
Those are your perfect square numbers you want to look for. So when we're looking to factor 40, we want one of them to be one of these numbers. Well, which one is the only one that works?
49.
49 is not a factor of 40. Remember, we're looking for two numbers that multiply together to 40.
4 and 10.
There you go. So I can write this as the square root of 4 times the square root of 10. And the fact that I have that means I can change that to a 2 with no radical sign. 2 root 10. That's my answer. Now, let's talk about root 10 for a second. What would that be?
That would be 1 and 10.
Okay, not bad. Not a bad answer at all. It's also 2 and 5, right?
Right.
But 2 and 5 are not perfect square numbers. So it's correct to write it like this, but it's not simplifying it. It's making 2 terms instead of 1. So I don't ever want to do this. I don't ever want to make square root of 10 into square root of 2 square root of 5. I want to leave it as square root of 10. Unless you can find a factor that is a perfect square, then you don't do anything with it. Okay? You with me?
Yeah.
Okay, let's try some others. Square root of 48.
Could you do 1 and 48?
Well, unfortunately, that doesn't help us. In other words, yes, you could, but then that just becomes 1, and we don't even write it, so you really haven't done anything. So doing it into the factors 1 and the number is never what you want to do. Is there a factor of 48 that's on this list over here?
No.
Actually, yes, 4.
Oh, yeah.
So this would be the square root of 4 times the square root of 12, which is 2 root 12. But now let's look at root 12. What is root 12 going to be equal to?
That 6. No.
What two numbers multiply to 12, one of them being on this list? No, not 1. Yeah, let's take this one off the list because you don't ever want that one.
4.
Okay, so that's the square root of 4 times the square root of 3, which is 2 root 3. So instead of this root 12, I want to write 2 root 3. So it's 2 times 2 root 3, which now becomes 4 root 3. So this is what the square root of 48 is equal to. Now, could we have gotten there quicker? Yes. In other words, if I happen to notice 16 is also a factor of 48. So it's 16 times 3. Okay, well, 16, what's the square root of 16?
4.
So it becomes 4 root 3 in one step instead of the 2 or 3 steps that we took. So you don't always have to find the maximum first. That's the best way to do it. In other words, the best way to find the square root of 48 would have been to factor it into 16 times 3, because we get to the answer in one step. Whereas the way we did it, we had to kind of whittle it down. We had to do 4 square roots of 12, and then we had to realize square root of 12 was not simplified. And we had to simplify it. Okay? So that's the name of the game. The name of the game is to find factors, and the biggest factor is the best. What's the square root of 100?
10.
It's the square root of 200.
20.
It is 20 times 10, but is that the best two factors? Because neither 20 or 10 are on my list.
50. No.
Well, you could do 50 and 4, but there's a better one. You just gave me the answer. What's the square root of 100?
10 and 10.
So let's make this the square root of 100 times the square root of 2. 2 times 100 is 200. And then I know that that is 10. So that's how I do square root of 200. Now, I didn't put 100 on the list over here. I didn't put a lot of things. This was 7 squared. That's 8 squared. That's 9 squared. There's the 100. There's 10 squared. Okay? But the fact of the matter is that when they give you problems to reduce, they're almost never divisible by these numbers over here. They're always divisible by 4, 9, 16, or sometimes 25. How about that?
By 25.
Okay, what is the two factors if 25 is one of them?
25 and 4.
How many quarters make up $1 and a quarter?
5, sorry.
And then that becomes, this is 5. So that's the answer. All right, let's see. How about this one? Square root of 72.
Oh, 9.
9 times what?
9 times 8.
Okay, so simplify that.
3 square root 8.
Now, let's talk about square root of 8. Can I do anything with that?
Yeah.
Okay, what is square root of 8?
You could do 4, 2.
So that becomes 2 root 2. So I'm never going to give this as an answer, ever, because it simplifies to 2 root 2. Okay, so I go back up here and I got 3, and instead of square root of 8, I'm going to put 2 root 2. Well, what's 3 times 2 root 2?
It's
6 root 2. Okay, now let's go back to the original problem. There's nothing wrong with doing it the way we did it. It just took 2 steps. Okay, if I would have noticed, it's also 36 times 2 is 72. What's the square root of 36?
6.
So it immediately becomes 6 root 2 in 1 step, not 2 steps. So all I'm really pointing out is that you can save yourself a little time by figuring out what the greatest factor that is a perfect square number is. Now, you don't have to try that many numbers here. You noticed that 9 was a factor, and that was correct, but 16 is not, 25 is not, 36 is. So we should use the biggest one if we notice it. Now, it's no big harm done if you don't notice it. It just means it's going to take you an extra step. Factors of 32, what are they?
For a second.
Here, let me put my list of perfect square numbers on there again. I noticed I don't have to look at any beyond those 4, because there's no bigger number than 25 that's going to divide into 32.
16.
Very good. So it's the square root of 16 times what?
2.
What's the answer?
4,
Perfect. I think you're getting the hang of it. What is the square root of 7 times the square root of 7?
I have no clue.
7. Just like the square root of x times the square root of x is x. Okay? Notice that I could have done a couple things here. Well, the square root of 7 times the square root of 7 is the same as the square root of 7 times 7, which is the same as the square root of 49, which is 7. In other words, this goes both ways. If I have the square root of something times the square root of something else, I can multiply those two numbers together and just put them both under the radical sign. It's the square root of 2 times square root of 5. Same thing as this.
10, right?
So it's the square root of 10. Yes. Okay. So as long as you're multiplying and they're both square roots, you can multiply the two numbers together and just take one square root. Now, there's a situation that comes up where you get an answer sometimes like this. Well, mathematicians have decided that this is an irrational number, the number square root of 2. In other words, it's approximately equal to 1.41, but it's kind of like pi in that it goes on forever. Never ends, never repeats. That's called an irrational number. In other words, there is no way to write that number as a fraction. And I'm talking the square root of 2, not 1 over the square root of 2. Okay? So let me start again. If I want to depict the number square root of 2, that's the most accurate way for me to represent it. It's not this. I don't care how many digits I write, I am never going to represent that number accurately. I could write 20,000 digits after the 0.41, and it would still not be as accurate as the square root of 2. This is the most accurate way to describe it. So at some point in math, and you're not there yet, but at some point you will get to where you do not convert these to decimals. You don't put that into your calculator and come up with a rounded off decimal. You just leave it as square root of 2. Okay? With me? All right. Well, what happens if that is in the denominator? That's a problem. Mathematicians do not like irrational numbers in the denominator. So there's a process called rationalizing the denominator. Well, how do I rationalize the denominator? I multiply this whole thing by the number 1. Only in our case, the number 1 is going to be square root of 2 divided by square root of 2. Notice that that is 1. I can multiply any fraction by 1 without changing its value. Well, once I multiply this, I get 1 times square root of 2 in the top. What's square root of 2 times square root of 2? 1. 2.
Or 2, right.
Okay. Now, look what we have. We have a new fraction that is exactly the same as that, only it's got a rational denominator. Now, it still has an irrational numerator, but that's okay. You can't completely eliminate the irrational part, but you can put it in the numerator, not the denominator. So this process is called rationalizing the denominator. So how would I rationalize that? Because for one thing, let's talk about irrational numbers. When I take the square root of a number that does not end up being a whole number, it is always irrational. In other words, these are all irrational numbers. Not square root of 9, because square root of 9 is 3. But any square root of a number that does not become, in other words, any square root of a non-perfect square number is an irrational number. So square root of 3 is irrational. So how do I rationalize that? Multiply it by what? Top and bottom.
The opposite, right?
Square root of 3. In other words, whatever this is. Not the opposite, the same thing. In other words, it's pretty easy, the rule. I'm just going to multiply it, the top by square root of 3, the bottom by square root of 3. What do I get? What do I get in the top?
Three.
1 times square root of 3. 1 times anything is anything, so the top becomes square root of 3. What's the bottom become?
3.
Does that work?
Yep.
Yeah, because we now have a rational denominator. And if you were to put it in a calculator, that right there, or this right here, it will give you precisely the same answer. In other words, this is the same number as that. The difference is this has a rational denominator, this does not. You will never see this as an answer on any kind of a multiple choice test. They're never going to give you 1 over square root of 3, because that violates the rule, which is do not put irrational numbers in the denominator. So what is this? What do I have to multiply it by?
Huh?
What do I have to multiply it by to rationalize it?
5 and 5.
Square root of 5. Okay, now what do I have on the top?
You have the square root of 10, right?
No, because you would if there was a square root over that, but there isn't. So it's just 2 square roots of 5. That's what the top multiplies together to. What's the bottom multiply together to?
5.
And there's your answer. And it's rationalized. All right, we'll end it there. That's good. We're making good progress. We're covering an awful lot of the algebra that you're going to end up needing to know. Garrett, I will talk to you next time.
Okay.
All right, bye-bye.